Okay, hi guys. So in this lecture, we'll be discussing on a new concept which is entropy. So let's get started with entropy. So it defines the degree of randomness or disorderness of system. It defines the degree of randomness or disorderness of a system. Okay, so suppose we have H2ON, which is liquid. Okay, gets converted to H2OG, rather NH2OG. So the delta S separation of this change would be positive. Okay, so we can write that delta S would be positive. Similarly, if we look at this example, that CH3 COH N, which is liquid, gets converted into N/2 CH3 COH twice. We have already discussed that CH2 COH actually exists in dimer form. So again, delta S for this reaction is also positive. Okay, so this is the gaseous form. Okay, so but if you have to compare between the entropy of one H2O molecule and one CH3 COH whole twice, which is in dimer form, then obviously the entropy of H2OG would be higher because this exists. So H2OG's entropy is more than CH3 COH's entropy because the only reason is that it exists in dimer form. Okay, so next let us discuss on another concept, which is the relationship between bond angle and percentage S and P character. So now we'll be seeing a new concept, which is relationship between bond angle and percentage S and percentage P character. Okay, so we can say that we are defining that we write, let's suppose theta is the bond angle, so we can write cos theta is equals to S upon S minus 1, which is equals to P minus 1 upon P. So this is a very important relationship, just keep that in mind. Okay, so this is only valid only if only S and P orbitals are involved in bonding or involved in bonding. Okay, and so we can write S plus P is equals to 1. Okay, so suppose we have, for an example, sp hybridized orbitals. So it is something like we have in between sp hybridized an angle of 180 degree. So let's prove this with this formula. So we have cos theta equals to percentage S character here is another fraction of S character is 0.5 divided by S minus 1. So this gives us minus 1. So theta comes around, other theta comes to 180 degree, so which is also proven by this formula. Okay, so in this case percentage S character was 50 and percentage P character was also 50. Okay, And if we take another example wherein we take sp2 hybridized orbitals, so in sp2 hybridized orbitals we have an angle of 120 degree. So let's prove the same. So percentage s character here would be 1 by 3, rather I'm just using the s fraction, s orbital fraction, rather the fraction of s orbital in sp2 hybridization or sp2 hybridized orbital would be 1 by 3. So just putting it in the formula, that is s upon s minus 1, so it is 1 by 3 divided by 1 by 3 minus 1, that gives us cos theta equals to minus 1 by 2. So this implies theta is equals to minus 120 degrees, rather theta equals to 120 degree. Okay, so from here with the formula or the relationship between theta and s orbital we are deriving the same result. Okay, so next let us see some facts here. Okay, so those are that as percentage s character of hybrid orbitals increases, we have also seen this before but again reiterating, if hybrid orbitals increase, this implies that the electronegativity of the bond or the atom participating in the bonding also increases, bond angle also increases, bond strength also increases, and bond angle decreases, bond length decreases. Okay, because bond strength and bond length have inverse relationship. Okay, so with this we come to the end of this lecture. So in the next lecture we'll be seeing more concepts. So till then, good luck and goodbye.